Now let's work on Chapter 6, Electronic Configuration Homework Problems. So let's take a look at the first question here. What is the full electron configuration of barium? So first thing first, we have to find out how many electrons that barium have. All right, so because we are talking about electron configurations, so let's take a quick look. Barium, that should be a group 2A element, so that should be somewhere right here. So the atomic number is 56. We already learned the atomic number equals the number of electrons. So therefore, we should have 56 electrons, okay, for barium. Okay, now, as I mentioned in the class, the electrons, when they place in the orbitals, they will start from the lowest energy level first. So therefore, should be always start with 1s, 2s, then 2p, then 3s, 3p, 4s. After that is 3d. Okay, you see 4s energy is lower than 3d. We'll talk about that in the future in the class. So that's because of the penetration of the fourth and higher energy levels. So very strong. Okay, so therefore each orbit can maximum accommodate 2 electrons, and we have 56 electrons. All right, then we just go with that order. So now, if you get lost with what I just talked about with the energy level, with that energy diagram, so again, you will just use this diagram. This is very useful. So you write down 1s, 2s, 3s, 4s, 5s, 6s, 7s. And then for 1s, remember, because of the allowance, so it cannot have any other higher energy levels. But for n equals 2, L equals 0 and 1, that's why it has P. All right, n equals 3, it has P, and then n equals 3, 3 minus 1, the allowance for L should be, so 2, L equals 2, which means then that's the D subshell. Okay, anyway, so you just write this and then 4s, 4p, 4d. Now, after writing that, you see, you will make a diagram, make a line like this. Okay, so the first 2 electrons goes to 1s and then come over here. Then the next 2 go to 2s. The next 2 go to 2p, and then 3s. Come back, 3p. Then 4s, you see. After 4s, you have 3d, 4p, 5s. So if you make this kind of chart, you will never go wrong. Okay? So let's just follow this chart, and we will complete question number 1, barium. So we have 56 electrons. Then how many orbitals do we need? So divide by 2. All right, so half of that should be 28 orbitals. Okay, so we need 28 orbitals. Okay, as I mentioned, we always start with 1s. Okay, so then let's write down 1s2, because 1s is 1 orbital and should accommodate maximum of 2 electrons. Then after that, so that should be 2s, 2p. How many electrons for the p orbitals. So there are 3 p orbitals, and then that should be maximum of 6 electrons. Then after that, that should be 3s2, 3p6, okay? And then 4s2, okay? So you see, after 3p, let's go take a look at here. After 3p, you will have 4s. Then after 4s, you have the 3d. You see? Okay. So, and then 3d, how many d orbitals? Or how many orbitals in the d subshell? That should be 5. So 5 orbitals, 10 electrons, okay? I'm going to kind of move them away a little bit. So after 3d, we will have 4, you see 4s, the next one after 4s should be 4p. Come on. Oh, what quantity is this? And try another one. Okay. So 4p, again p orbital, 3 orbitals, 6 electrons. And after 4p, it should be 5s. And then after 5s is 4d. Okay, so again, if you use this chart, you will never get that wrong. So after 5s, you go this way, and then that's 4d, 5p, 6s. Okay, so that's 5s, and then 4d. Again, d should have 10 electrons, and then 5s should be 5p, another 6, and then after 5p we have 6s. Okay, so that's the 4 electron configuration for our barium, and we just said there should be 56 electrons, and that would need 28 orbitals, okay? But let's count the number of electrons, see if it's correct. So we have 2 plus 2, that's 4, plus 6, that's 10, 12, plus 6, 18, plus 2, 20, 30, 36, 38, 48, 54, 56, bingo. So that's how you work on this one. And if I may, you see this tells us barium is actually in the 6th period, all right? So let's confirm, okay? So barium, N equals 1, 2, 3, 4, 5, 6. Okay, so everything come together. That's question number 1.